Welcome everybody. Probably good afternoon to most of you, maybe good morning, good evening, to our 74th webinar already. Wow, it's growing and it's growing, the number. I'm very pleased today to have Tine Starič. I met Tine last, what was it, spring, summer, at Days of Knowledge in Denmark. I think it was the first time. It was nice to talk to you, and I was very impressed by the webinar, no, not the webinar, the presentation you did with this topic. And I asked you, would it be possible to repeat this thing, as I think the contents is very valuable. And I was very pleased, Tine, that you stepped in. Tine is working at Companion, located in Vilnius in Lithuania. And as I understood, you're at the office right now out there. I'm going, of course, giving you room to introduce yourself a little bit more. But before I do, I always go through a couple of, let's say, housekeeping things like this slide for everybody that's here. Most of them, looking at the list, are acquainted to this. If you're not, you're really welcome to interact, but we don't unmute your microphone. Your microphone is muted. There is a question window, and please, if you have questions or also compliments, whatever, put them in there, and I, Luc van Vugt, your moderator, will pick them up. We agreed, Tine and I, that we will keep them to the end for the Q&A at the end, unless there's something else relevant, I don't know. But Tine wants to, let's say, deliver the full story, and it's probably also a bit of tight schedule, so we'll push the Q&A to the end. Everything will be recorded, you might know, and of course, you will find it on our Areopa webinars channel on YouTube, and probably already this evening, and use it to your own for whatever replay, but also feel free to share it with your colleagues, customers, whomever you think this is valuable for. There are 70 plus recordings out there, so if you haven't been there yet, go through it and see if there are things valuable to you still. If you want to be in the know directly when we schedule new webinars, feel free to subscribe to our newsletter. Let's say it's another very descriptive link, but it's short enough to now type and get yourself subscribed to the newsletter. It's not let's say a regular published thing. It's published as soon as we have something new to mention. And something new is about upcoming webinars. Everything, there are 2 left at the moment. One in 2 weeks' time by Arjan Kaufman on October 30. Another one at the start of December by Waldo. And as you can see, there's a gap in November. Nothing set yet there. I'm working on one myself, so there's something I'm going to do probably in November, but I need to check a couple of things if it fits well. And as you know, there is this there are directions in between. So as Tine also said, he's preparing for directions, doing a couple of sessions there. I'm also preparing for directions. So it depends a bit. But if you want to be in the know, you can always find it on our website. But if you want to be, let's say, triggered by a newsletter, feel free to subscribe to it. Of course, we're always looking for new topics. And as you can see, there's a gap for November. If you have some topics, just as topic, you want to suggest them, send it to us. If you want to be a speaker, and maybe that's a big step to do. On the other hand, I've been coaching quite some speakers already. So if you really think, well, this might be something for me, but I need help, please let me know. And before I'm going to hand over to you, Tine, I'm going to thank our sponsor for enough to enable us to do this using GoToWebinar. So what I'm going to do right now is make you presenter, Tine, and then you should be able to share your screen. Yeah.
Okay.
Clearly in view.
Thank you.
And I can hear your voice too. So great.
Good. So thank you. Thank you, Luc. Thank you for having me. And to everyone else, welcome to a webinar about unlocking the secrets of secure endpoints, connecting Business Central with advanced authentication techniques. I did this session a couple of times in the past year, but I'm actually really glad that it's now turning into a webinar, because the skills that I want to share with you today are not something that you are going to need or use in your day-to-day lives. But at the same time, well, every so often you are going to come across some endpoints that have a higher security standard than just passing basic authentication header. And when you do come across such an endpoint, well, I hope you'll remember that there's a recording of this webinar that you can take a look at. When I was preparing, so how did I come up with this session? It was last year when I got onto a project where I needed to integrate Business Central with a bank. And the bank is the perfect example of an organization that has a higher security standard. And as I was navigating all of these more complex requirements, I was thinking to myself, why not collect all of these lessons learned and share it as a webinar? But now, before we get deeper into the presentation, I would like to first take a minute to introduce myself. My name is Tine Starič, and I'm a software developer at Campanio. From the development side, I mainly work with AL, but a lot of the times I also play around with Azure resources, or I meddle around with what Power Platform has to offer. Aside of being a developer, what I'm really passionate about is bread. I really like making sourdough, and I'm really passionate about all of the baguettes. Additionally, I am currently relocated in Lithuania, but originally I come from Slovenia. And before I relocated, I used to have my own beer brewery back home. So my kind of goal is, after I'm done with my time in Lithuania, is to relocate back and pick that hobby back up, because I don't know, I feel like beer is a really good conversation starter when it comes to talking to new people.
And it's a Slovenian tradition almost, I think.
Maybe. It's picking up, definitely. Anyway, that's enough about beer, enough about bread, and let's get deeper into our actual topic. So what are we going to talk about today? I'm going to start with OAuth 2. And why I think this is the most important part, it's because this is going to be the most common requirement you're going to have in the future when you try to access more secure endpoints. We already know that, for example, for Business Central Online, you can no longer reach those APIs with just basic authentication. You need OAuth 2. But in there also lies the problem, because every time that you try to Google Business Central OAuth 2 or AL OAuth 2, the only things that come up are a bunch of blogs and a bunch of documentation, how you can set up your own app registration, and how you can use Postman to then reach those APIs. But we don't have Postman. We have AL, and we need to reach the external endpoints with AL. And this part of the story, we will branch into two parts. One is if the endpoints are behind Azure Active Directory, or the new name is Entra ID, but honestly, I'm still not used to using the new name. So throughout the presentation, I'll still be referring to it as Azure Active Directory. And the other part is going to be if the endpoint is behind a third-party identity provider. The reason for the split is that if the endpoint is behind Azure Active Directory, Microsoft already gives us a really nice system module that we can use to simplify everything. And if we're dealing with a third-party identity provider, we need to do more of the heavy lifting ourselves. Next, we're going to move on to security certificates. We're going to talk about how they are used in the integration scenarios, how do they work, and we're going to take a look at a demo. How can you sign an HTTP message content in AL with a certificate? Then we're going to move on to IP whitelisting. We won't spend too much time here because, well, IP whitelisting is nothing new. It's older than NAV itself. but there's still some additional challenges that have been brought by everything moving to the cloud. And lastly, I hope there's going to be a bit of time left. I'd like to kind of share my perspective on key vaults and what are key vaults, how you can use them, and when should you use them instead of isolated storage. Okay, so let's start with a brief overview of OAuth 2. I won't go too thoroughly through this, but at the same time, I also kind of want all of us to be on the same page so we kind of have the same understanding as we're moving through the code later on. To understand OAuth 2, let's first take a look how integrations used to work in the old days. Whenever you were trying to request something from the resource server, you simply sent a message with basic authentication. If basic authentication was valid, you would get yourself a response. But imagine a scenario where you have a malicious actor now in between that has managed to intercept one of your messages and extracts this basic authentication out of your request. The problem is you won't know that the message was intercepted, but this malicious attacker can now start sending their own requests to the resource server, and they will get the response each time. But in OAuth, we're no longer sending basic authentications. We are no longer sending usernames and passwords. Instead, what we're doing, we're passing around tokens. You can think of tokens as those short-lived passwords that are only valid for something like 5 minutes. And if you imagine the same scenario where someone has managed to intercept one of your messages and extract a token out of it, they will only be able to use that token for the next 5 minutes, and then the token expires. So this token and the short-lived passwords already brings a much better security than just basic authentication. But the question with tokens is, well, where do we get those tokens from? To understand that, we need to know that in OAuth, there's a third party now involved that I'll refer to as the authorization server. There's multiple ways how you can get the tokens, but I'll mainly be talking about two today. One is the service-to-service flow, where there's no user interaction required. When it comes to service-to-service, the only thing that you need to know and understand is that you require a client ID and a client secret. So you just send a request to the authorization server with your client ID and the client secret, and the authorization server will respond back to you with a token, and you can then use that token to reach your resource server. This one is quite simple to understand, and it's also quite simple to implement. So that's the one we won't be spending too much time on. But the one that is more difficult is the auth code flow. This is the one when we do require a user interaction, when we want for the user to sign in before we actually get the token and send a message forward. To understand this one, since it's a bit more complex, let's break it down into 3 steps. The first step is the authorization part, where we have to send the user to the authorization site, where they will log in by entering their username and password and maybe 2-factor authentication. And this is normally the screen that you would see, that you would display to your users. Once the user has successfully authenticated on the authorization site, the authorization server will generate an auth code. And it will send this auth code back to us, back to Business Central. And we have to be listening on an endpoint that will later refer to as the redirect URL. So the first step is we send the user to authorize. And then the second step is we have to be listening for when the authorization server responds back to us with the auth code. And once we have the auth code, we have to send a message back to the authorization server with this auth code. And the authorization server will give us back a token that we can then finally use to request a resource from the resource server. Let's take another look at this schema, but this time through the prerequisites that you require every time that you're dealing with OAuth 2. The first point says client ID and client secret. I won't go any deeper into these two because for you as a developer that's trying to implement OAuth 2 flow, you should consider these two as a given. They should be given to you from whoever set up the app registration on Azure or app registration on Google. It doesn't really matter. Next, you will require an authority URL. If we take another look at this schema here, the authority URL is the place where you send your user at the very beginning for them to authenticate. Next, we have the redirect URL. As we mentioned earlier, this is the place on our side, on Business Central side, where we have to be listening for when the authorization server will reply back to us with the auth code. And once we have the auth code, the token URL is again on the authorization server side. This is where we request the token from. Next, we have scopes. You can think of scopes as sort of permission sets. So if your resource server, the API will, for example, create a customer, then it will require write permissions from that token. So when you request a new token from the authorization server, you already have to say, please give me a token that has write permissions, because the resource server won't only validate if the token is valid, it will also validate if it has all the necessary scopes, meaning all the necessary permissions. Finally, we have state. State is just one additional security factor in this whole framework. You can think of state as just one randomly generated code that we are going to send alongside authority URL in the first step. And when the authorization server replies back to us to the redirect URL with the auth code, it will also send this state back to us. And we can then verify, is the state that we send at the beginning the same as the state we got back? Then the authorization succeeded. If there would be a mismatch, then something went wrong and we have to throw away this authorization attempt. Okay, that's enough about the theory around OAuth 2. So now let's move on to see how we practically use it, how it looks in the UI, and what's the code needed to get something like this going. So I'll switch over to my Business Central instance. Let me log in. There we go. For this session, I built a simple endpoint tester page. To shortly explain what this does, on the endpoint tester, you can select many different endpoints that we will be testing today. You specify different token getters that you can use to actually retrieve the OAuth token. You specify if you would like to sign that HTTP message with a certificate. There's a button to send the request, and in the bottom part, the response is being displayed. So let's start with our Azure Active Directory endpoint. And if I try to send a request to this endpoint without any tokens, you'll notice that I get a 401 unauthorized because the token is not present. Now, if I set the token getter to service, this, as you remember, is the non-user interactive way of getting a token. When I click send request, nothing will happen, but at the same time, this time we have successfully reached our Azure Active Directory endpoint. But this one's kind of boring, so instead, let's take a look how it looks when we try to get the token from Azure Active Directory. In this case, when I send a request, you will see all of the steps that we mentioned earlier. The first step is a pop-up is thrown, and it points the user to the authority URL, where now I have to log in to supply my username, my password, And it will even request two-factor authentication. So I need to enter 23 on my phone. Yes. Okay, stay signed in. Sure, why not? And then now in the background, the auth code was retrieved, the token was requested from the token URL, and then finally that token was used to, again, successfully reach the Azure Active Directory endpoint. So now let's take a look at the code side of things. I'm gonna switch to my Visual Studio. And let's start with the procedure that gets invoked every time that I click send a request. Every time I click send a request, this get top secret info is invoked. Depending on which token getter I selected, I'm gonna get my token. Depending on which endpoint I selected, it will build a request message. Basically, it will just set the URL. It will specify if it's a GET or a POST request, and it will add the token as one of the headers. And then if the sign message toggle is enabled, it will also sign the message content with a certificate, but more about that later. Then the request message is sent, and the response message is then parsed and displayed on the UI. So let's check how we can actually get those tokens, because that's the things that we are curious about. First, I'm going to show you how you can get the token using the service-to-service token getter. This one is easy to implement regardless if it's for Azure Active Directory or if it's for third-party identity provider. So let's just start with this one. With service-to-service, we don't need the authority URL and we don't need the redirect URL because we're not dealing with auth codes. We're not sending the user anywhere. So we can immediately move to sending a message to the token URL. And in Azure Active Directory's case, it's login microsoftonline.com/tenantid/auth2/token. In your case, this link would be exactly the same, except for the tenant ID being different, obviously. We're going to send a post message, and in the content, we're going to specify brand type equals client credentials. We're going to specify our app registration's client ID. We're going to get the client ID. We're going to specify the client secret. And with these two, the client ID and the client secret, what I would like to mention here is that client ID is public information. You don't really have to hide this. You can if you want to, but there's no need for it. That's why I have it just hard-coded in my source code over here. But the client secret, on the other hand, as the name suggests, it's a secret, and you should never keep your secrets in your source code. I would also say do not keep your secrets in your tables. Use either the isolated storage or a key vault. And in my case, I'm using a key vault, and I'm always getting a secret from my key vault. Once I have this content text created, I add a couple of headers to the request, but essentially I just send the request, and when I get back a response, we do some JSON token magic, and out of this response, we parse out the access token, and that's it. We got ourselves an access token. Now let's move on to the other token getter that we saw, the one where we do require user interaction. This one, in the case of Azure Active Directory, is actually going to be even simpler. As I mentioned at the beginning, Microsoft has been kind enough to grant us access to their system module that they are using for authenticating with AAD. So for the majority of your use cases, you simply can refer to this code unit, OAuth2, and let's take a quick peek inside it. You'll notice that this code unit has a large number of procedures over here. It has all the different overloads to acquire tokens by authorization code, acquire tokens by authorization code with certificate, to get only the access token, to get the access token and the refresh token, access token, refresh token, and the ID token, whatever you need. And as I said, for majority of your use cases, if your endpoint is behind Azure Active Directory and you're trying to implement it with the auth code flow, you will find what you need inside this code unit. In our case, we're going to use acquire token by authorization code. So let's walk over the parameters that are needed for this to get working. First, we have the client ID and the client secret. These two are exactly the same as with the previous example because it's also the same app registration. And then we have the authority URL, the URL where we are going to send our user once the pop-up is opened. In Microsoft's case, that's login microsoftonline.com/tenantid/auth 2.0 authorize. Again, the link would be the same in your case, just with a different tenant ID. After we have the authority URL, we need the redirect URL. For the redirect URL, as you remember, this is now on Business Central side. This is the place where we have to listen for incoming messages from the authorization server with the auth code. And there's two types of redirect URLs that you kind of have to keep in mind. If you're on SaaS, you only need this one, businesscentral.dynamics.com/authlanding.htm. And you can see from the structure of this get redirect URL procedure, all I'm doing is checking if environment is SaaS, then exit this one. If it's not, meaning it's on-prem, then we have to build our redirect URL from the server base URL, and we're gonna add the authlanding.htm at the end. This get base URL procedure is just a helper function that will extract the server's base URL out of the current web client address. To give you an example how this would look in my on-prem scenario over here, you can see that I have a huge link currently in my browser. That get base URL procedure is going to take all of this in the AL code and extract this part out of it. HTTPS cloudbc on-prem North Europe cloud app azure.com/bc, and it will then add next to this base URL the /authlanding.htm, and that's going to be my redirect URL. Next, we have the scopes. We talked about scopes being some sort of permissions, and you can see that in my case, I only request for user.readscope. You could request for multiple scopes because scopes are a list of text. The last input parameter is the prompt interaction. Now, I won't go into the details of all of the different options that you have here. If you'd like to know more about each one of them, just check the documentation on the enum because everything's explained there. For our case, we're using login because this will force the user to log in every time that they would like to send the request. And then we have the two return variables. We have the actual access token, and we get any potential errors that might have occurred during this authorization phase. If any errors have occurred, we're going to throw them. If not, we have just successfully gotten ourselves an access token from Azure Active Directory. Okay. So now we know how to get tokens from Azure Active Directory, either with user interaction, either without user interaction. But what about if the endpoint is not behind Azure Active Directory? I'm going to show you a quick demo how you can get a token from Facebook. Why am I using Facebook? Well, because their developer portal was easy enough to set up for me to kind of showcase what I want to show to you today. So let's first start at our endpoint tester again. This time, we're going to try to reach an endpoint that is secured by Facebook's identity provider. And if I try to reach the Facebook endpoint with an Azure Active Directory token, when I send the request, you'll notice that, well, it didn't succeed because it has an invalid access token. So if I switch to my Facebook token getter and I send a request again, you'll see that for a brief moment, the pop-up appeared, but then it immediately went away. And now we have successfully reached the endpoint. The reason behind it? Well, it's because there's single sign-on. Because I'm already logged into Facebook in one of the other tabs, the single sign-on said, oh, wait, I already know you. So you're good to go, you're authorized, here's the token. But just to make sure you believe me that we're actually getting the token from Facebook, I'll show the same behavior in an incognito mode. Let me just log in here. I'm gonna select my Facebook endpoint, Facebook token getter, gonna send a request. And this time you see that I have a pop-up and it's requesting me to log into Facebook in order to actually get the access token. But we don't need it because we've already gotten it from the previous example. So let's take a look at the code side of things for a third-party identity provider. I'm gonna switch on over to the Facebook's token getter over here. Now for Facebook, and well, for any third party, it's more complicated than just calling a procedure from a code unit that does everything for us. To make things a bit more controllable, we're going to split this again into three parts. In the first part, we're going to build ourselves the authorization URL. In the second part, we're going to open the pop-up page where we're going to send the user to the authorization URL. And within that same page, we're also going to be listening on the redirect URL for when the auth code is returned back to us. And once we have the auth code, we're going to build the token endpoint and request a token from it. So to build the authority URL, in Facebook's example, we need this URL, facebook.com/version/dialog/auth, and we pass in the client ID, redirect URI, and state. Client ID, same as before, public information, client secret later. Again, it's a secret, so I keep it in my key vault. Redirect URL is exactly the same as it was in the previous example because, well, this is still on our side. So on our side, nothing has changed. And finally, state is what I've talked about earlier. It's just a random code that I generate, which I'm going to send alongside my authority URL, and I'm going to validate once I get my auth code back from the authorization server. Why we didn't have to deal with state in the Azure Active Directories example, it's because the code unit did everything for us. So now that we have the authority URL, we need to move on to the, I would say, the most complicated part, where we have to raise the pop-up, we have to send the user to a specific site, we have to wait for the auth code to hit our redirect URL. But luckily for us, we don't have to deal with all of that JavaScript because we can almost reuse everything that Microsoft is using when they're doing their whole authorization code. Microsoft is using a page called OAuth to control add-in. I'll show you how that page looks like. This is a page taken from the system application, page 502, OAuth to control add-in. And you can see that this page has some JavaScript add-in that does all of the magic. It has the perfect triggers, authorization code retrieved. It has the trigger authorization error occurred. And when I saw this page, I was really happy because I was like, yes, I don't have to deal with JavaScript. I can just reuse this and it will work for my case as well, which is not Azure Active Directory. Well, almost. For some unknown reason, Microsoft marked all of the procedures on this page that either set the global variables of the page or get the global variables of the page as scope on-prem. Why have they done this? I don't really know. I've actually opened an issue with them a while ago. There was no real progress on it, but because the workaround is so simple, I didn't really bother too much with it. What we have to do to get all of this working in the SaaS world, well, we basically have to copy the whole page and remove this scope on-prem tag. So that's what I did here. You'll notice that it's basically the same page, Auth to control add-in, but in the 50,000 range. It's still using the same JavaScript add-in. It has the same triggers for when we receive the authorization code. It has the same triggers for if there's any errors, but with this major difference that all of the procedures are not marked as on-prem only. So once you have that cleaned up, if we return back to our Facebook token getter, it's actually not that difficult to use. All you do is you set the global variables for the authority URL and the state, and you just run that page. And the JavaScript add-in will open the pop-up, it will send the user, it will wait for the user to authorize, and it will get back the auth code from the redirect URL. And once it's done, you simply retrieve it from that page. You get the auth code, you get the auth error if any occurred. If it happened, you want to throw that error. Otherwise, we are now ready to build ourselves a token URL. To get the token, in Facebook's example, they're using a URL graph facebook.com/version/auth/access token. You pass in the client ID, redirect URI, client secret, and the auth code that we just received. So that's what I'm doing over here, just replacing all of those placeholders with the client ID, redirect URL, client secret, and the auth code. And from here on out, it's just a simple get message. When we get back a response, we parse out the same as we did before. We parse out the access token out of that response body. And there we go. We have just successfully gotten ourselves an access token from a third-party identity provider. So that's how much I want to share on the Auth 2 part of the story. Now let's move on to the security certificates. Security certificates in the integration story are used for data integrity. You can imagine if the sender is going to use part of the security certificate known as the private key to create a signature, and then the receiver of that message will use the public key to verify if that signature is correct. By using security certificates, you enable the receiver, you give the receiver a tool to verify, is the message that I just received the exact same message as the sender originally sent out? And to understand a bit better how does that work, let's take a look at this example I have over here. Let's say I'm building a really simple HTTP message that has a JSON body like this, a pair of name and Tine. So the first thing that sender will do is it will use a hashing function, something like SHA-256, and it will calculate the hash of this body, of this content. Next, it will use the private key of the security certificate to encrypt this hash, and that's how we're going to end up with a signature like this. Then we take this signature and we add it as an additional header to our HTTP message, and we send it off to the receiver. So what happens on receiver side? The receiver will take our signature from the HTTP header. It will use the public key of our certificate to decrypt it, and inside it will find a hash, the same hash that we encrypted earlier. At the same time, it will calculate the hash of the body that came with this message using the same hashing function, and then it will compare the two hashes. If the hashes match, then the request is a success and the receiver will process it and give out a response. But imagine a scenario where somebody has managed to intercept our message and change the body to something like name John. In this case, what the receiver will do, again, the same thing. It will use the public key to decrypt the signature. It will find a hash inside. It will calculate the hash of this body that came with it. Of course, the hash will be different because the content has changed. And because these two hashes now do not match, it will not accept this message. And it will say, nope, sorry, something went wrong. This is not a correct message. So maybe to sum up security certificates, a couple of things that maybe it's good to know is with the security certificates, you have two parts, the public key and the private key. The public key, you can share with everyone. The private key, please don't. Keep it secret. It's used for data integrity because it gives the receiver a tool how it can verify that data has not changed, that it wasn't tampered with. I'm going to show you a demo how we can sign the HTTP message content within AL, but it's commonly also used not only to sign the content, but also to sign the header, because the attacker could also tamper with the headers, and we don't want that. And it's also commonly used when you want to secure your FTP integrations. That's actually where I first came to hear about security certificates. Because imagine a scenario where Business Central just drops off a file on the FTP server. A processor, before it picks up that file, somebody else could come and change that file, replace it with a different file. And when the processor would start to actually process it, it wouldn't know that the file has changed, and it would just say, hey, yeah, I've successfully processed the file you sent to me. Now, if you send a file with a signature attached to it, and somebody manages to change that file, the processor will first verify if the signature is still correct. And if the hash of the file has changed, well, then it will know, wait, this is not the same file that somebody has uploaded. This is not okay. I'm not processing this. Please change. So let's check how we can sign contents of the HTTP message within AL. I'm going to go back to my Endpoint Tester over here, switch to the certificate endpoint. We no longer need the token getters because it's not secured with token getter. And if we try to send a request right now, we will get a response that it has an invalid signature. So if I try to toggle on the signing of this HTTP message and I send the request again, well, this time we get a success message because the certificate endpoint has been successfully reached. So let's see what's happening on the AL side of things. I'm going to jump to my very first procedure that we saw here. This time, we don't have any tokens. We have our request message for the certificate endpoint. And now we are going to additionally sign the message content. So let's check what's happening over here. There's three parts to this one. First, we get the content out of the message. If there's no content, then there's nothing to sign, and why are we even using certificates then? Next, we're going to create the signature out of this content, and we'll get to this part, how the signature is actually created, in a bit. But once the content signature has been created, we are attaching that content signature as a digest header. Why a digest header? Well, that's how the certificate endpoint is configured, that it will first try to get the digest header, and its contents is what it will compare to the actual content of the message it received alongside it. So let's take a look. How do we create the content signature? I'm gonna jump to my certificate signer over here. And for this one, we are using, again, a couple of code units from the system app. We're gonna use the cryptography management to actually sign everything. And we're going to use the signature key to extract the private key out of our certificate. So the first part is we're going to extract the private key, and I'll get to that in a bit. For now, let's just say, yes, we have the private key in our signature key code unit, and then it's just a simple procedure call. We pass in the data that we would like to sign. We pass in the signature key where the private key is stored. We specify which hashing algorithm we want to use, and it has to be the exact same hashing algorithm that the endpoint, on the other hand, on the other side, will be using as well. And then the signature is written onto the signature outstream. Finally, the signature outstream is just converted to base64 text because we need text to attach to our HTTP header. So if we just briefly return back to the signature key requires three things. It requires the certificate. Let me just open the inlay hints for you. It requires the certificate. It requires the passwords to that certificate. And then it's asking us, out of this certificate, would you like to only extract the public key or also the private key? And because we're doing a signature over here, we want the private key as well. Certificates, just as client secrets, are something that you should keep safe if they contain the private key. If the certificate only contains the public key, feel free to share it with everyone. But for the certificates with private keys, I also keep them in my key vault, which is a safe place. And because I'm storing it in a key vault, which is a safe place, you notice that I'm also not passing any passwords into this signature key code unit because the certificate is already unlocked. It's not password protected because, well, it's stored in a safe place here. And that's how you can use AL to create a signature with your certificates to, well, to reach the endpoints that have this security requirement. Next, and the last part is we have IP whitelisting. For IP whitelisting, well, this is nothing new. What you had to do in the past was with your resource server, you had to whitelist the IPs from where the requests are going to come from. And that was really not a difficult challenge because in the past you had one on-prem Business Central server, you figured out that server's IP and you whitelisted that. But now with the BC Online, you have more than 40 different IPs where the requests could be coming from. And you have no idea if Microsoft is going to add an additional IP, if it's going to remove an IP, if it's going to repurpose that IP. And to solve this issue, well, the solution is also nothing really novel. What you do is you introduce something of a proxy, something like an Azure function that is going to have a static IP. And you set up all of your Business Essentials that they send the requests to your proxy, to your Azure function, and the Azure function relays it back to the resource server. Now, that's a good approach, but the only problem here is that now anyone, like an on-prem server or an external app, if they manage to reach this Azure resource, that Azure resource will immediately relay the message to the resource server. And what we got about 6 months ago with the previous Business Central release are service tags for Business Central Online. You can think of service tags as a friendly name for a list of all of the IPs from where requests can come out of BC Online servers that Microsoft maintains. And by specifying a service tag on the Azure function, what you do is you protect it so that only Business Central Online servers can reach your proxy. No external app, no on-prem server, nobody else can actually reach it. So let me just quickly show you how you can do that, how you can use that, and how you can set up that service tag. So I'm going to try to reach my whitelisted endpoint, the one that has strict static IP requirements. When I send the request, you'll notice that it's actually a success. Why? Well, because this is an on-prem server, and it was really easy to figure out what's the static IP of the server and whitelist it. If I try to do the same thing out of my Business Central Online server, I'm going to select my whitelisted endpoint over here. If I try to reach it, you'll see that instead I get a 403 IP forbidden, because there's just too many different IPs that I would have to whitelist. So instead, what I have is a proxy. So if I try to reach the proxy out of my Business Central Online, now you will see that we get the same success response message as we did before. But additionally, if we try to reach this proxy from a server that is not in Business Central Online, that's not Business Central Online, you'll notice that when I send a request, I get the IP forbidden. That's because our proxy is set up with a service tag to only allow IPs from Business Central Online. So let me just show you how you can set that up. We're going to go over to the Azure portal. You'll notice that here I have the function app called IP Whitelister. All it does is it takes the incoming request and it forwards it, but it will have a static IP this time. But we don't want just about everyone to reach this function app. So to set it up with the service tag, we're going to go down to the networking part. This is where you set your access restrictions. So we're going to go to the access restrictions over here. And you'll notice that I already have a rule here, but still, let me just show you how you add a new one. You go over to the add over here, you specify a name for it, let's say BC Online 2. And instead of specifying all of the IPs that can access your Azure resource, you select a service tag. And in the selection of service tags, we can just search for Business Central. Now here I'm getting an error because I already have a rule for this one, but that's how you could set up an additional rule for your Azure resource. And that's how you can protect not just Azure functions, most of the Azure resources, so they can be only reached from the servers of Business Central Online. Okay. Now, I see that we are running out of time, so I'll keep this part short. Just a brief kind of comparison between key vaults and isolated storage. Generally, the most important point that I'd like to make is do not keep secrets in source code. Keep them secure, either in isolated storage, either in key vault. Doesn't really matter. But for you to start thinking, when should I use key vaults instead of isolated storage? Think of it like this. If you're storing secrets for each of your customers individually, so each of your customers gets a different secret that needs to store in the environment, use isolated storage, completely fine. But if you're sharing the same secret across multiple of your Business Central customers, then start thinking about key vaults. Imagine that you have an Azure function that all of your BC customers are trying to reach. And with each of them, you need to store the API key to that Azure function. You can simply store that API key in a key vault And every time that you update that secret in the Key Vault, you're not going to break all of your Business Central customers, because every time a customer would require a secret, it will connect to the Key Vault, it will get the most recent secret, and it will use that whenever it's trying to talk to the Azure function. One important part to note about Key Vaults is that on SaaS environments, they're only supported for app source apps. For per tenant extensions, you cannot get Key Vaults working. So that's something to consider if you're only developing for SaaS, because you will have a hard time developing something new on the sandbox. Other than that, that's everything from my side. Thank you for listening to this quite technical presentation, I would say. I'd like to mention that all of the code examples that we just saw are available on GitHub. Here's the link, but I think we can probably add it to the recording as well on YouTube. Otherwise, find me on Twitter, find me on LinkedIn, and if you have any questions, reach out.
Well, very clear again, Tine. There were no questions. Thanks from Gert Hector, who had to leave earlier. I have myself a couple of questions. One which maybe, I'm not sure, I think it links to this. I know that AJ Kaufman had done a pull request on, I think, Auth, that he updated actually the Microsoft code somehow, or he rewrote it. Is that indeed true, or am I linking something which doesn't link to this session?
I have seen it on Twitter, that discussion.
Yeah.
I'm not sure where he's at with that pull request. I don't think it was merged yet, but
okay.
Yeah. So for everyone else, AJ is adding to the system modules that will enable us to write more clean code to reach various endpoints. But I suppose he'll also write a blog post about it once it's done.
Yeah. Okay. So that it wasn't wrong, but it's good to know that there is probably not yet finished. You made a copy of that OAuth control engine page as a workaround, and of course, as you said, you contacted Microsoft, but no reply so far. Do you think this will change with AJ's changes or whatever in the near future? So would it be hard to keep in sync with Microsoft on that one? What are your expectations?
No, I do want to start pushing Microsoft to do this, just because it's a really small fix.
Yeah.
But I don't expect for anyone to have difficulties maintaining their copy, because most of the magic is on the JavaScript add-in that we're basically reusing. We're using the same JavaScript add-in as Microsoft is using.
And might be that now this is also part of a GitHub repo where we could, let's say, create a pull request to ask them to accept it.
True. Also a valid point.
Yeah. And there was a small other one not related to the topic, but I liked what I call now structure coloring in your VS Code. You have some app, some extension on VS Code where lines are colored so you can see the structure in your code.
Let me switch to it.
Yeah,
and
so
I'm sorry, but I'm gonna switch back to the dark theme because I'm confused.
Yeah. I asked Tina to go for a light one because of the recording. So now the coloring is a little bit less, but on the left side in the before every code
this
line,
one.
that one, yeah. So
yes.
You can see different coloring. If the structure goes deeper, it changes the coloring. What extension is that? Do you know that? Or is it?
It's a good question. I just recently installed it. Let me try to find it. I have so many. I think it's this one.
Yeah.
Indent Rainbow.
Great. Yeah, I liked it very much. It's better seeable in the light theme.
Yeah, but it does help. I like it.
Yeah. So we're almost at the hour. So in that sense, great that you kept an eye on time yourself also. I want to thank you, Tine, very much for this clear presentation. A compliment to that one. For me, it was very clear from the start to the end. There is something mentioned here. Oh yeah, there's two things mentioned from Arthur, so let's pick that up. Arthur van der Voort. I'm not used to work with certificates. Working with client ID and secret seems secure enough. When is switching over to certificates a must do? Or what is your advice on this?
Well, to be honest, most of the times it's not our choice, right? It depends how the the API provider has decided to secure things. So in my experience with the bank, for example, they were using both. So I first needed to get the token, but at the same time, I also needed to sign both the message content and the message headers with the certificate. That way, the API knew, okay, nobody who's not authorized cannot reach this API. And at the same time, even if someone does manage to intercept your message that has a valid token, they won't be able to modify the content because, well, we have the certificates to ensure that the content and headers weren't tampered with. So it's not one or the other. It can be a mixture. It all depends how risk averse the API provider wants to be.
Clear. Thank you very much. Well, let's round off. Thanks to everybody for being here, and a great thank you from Arthur for your answer. See you in 2 weeks' time with the session by AJ Kaufman on the business events. And well, thanks again, Tine, for being here.
Thank you for having me.